Welcome to another exciting educational video brought to you by Chrysler Light Tutors. So today we'll be looking at JAMB Physics. I would like to show you a resource that we have developed for our students. It's known as the Chrysler Light Tutors CBT series. This is a series of questions that we have developed for you to practice for your JAMB, and it simulates the CBT style. You just DM us and we'll send you a link for a token. An example is what I have here. I'm having this particular program, this particular subject, mathematics set 1. All you need to do is to just go ahead and acknowledge your email address and then begin to solve the questions. So I will just go through the questions. Let's say, for instance, you are solving and picking your answers. I'm just arbitrarily showing us how this works. So I'm picking the answers to these questions. This, of course, if you have studied and you are doing the solving. So I'm picking the answers, assuming that you are actually solving them and getting it. So I will just go through. Let's say I have finished with everything, and I will click on submit form. And the next thing I will see is to view my scores. So I view the scores and I see my scores and I see my performance. So this resource is available for you if you contact us. We have for math, physics, chemistry, biology, and English, 8 in 1. 8 in 1, that is 8 sets. So each set contains 50 questions for your practice. They are carefully simulated choosing questions aimed towards this year's JAMB exams with high predictability and for you to study and assess yourself even before the exam. You can see with my own trial and error here, I'm getting 14 over 100 in mathematics. I'm sure if you do your due diligence, you will get more scores. So it's available for you for a token of 2,000 naira per set subject. That is a set of 2,000 naira. Just send us a DM or the number at the comment section will get to you. So back to what we have for today. We'll be having JAMB Physics, and I'm going to start the presentation. So this is Chrysler Light Tutors, where we master calculations, excel in science, and learn anytime. So we're going to be dealing with questions that are in waves, sound, and light. JAMB past questions physics that covers wave, sound, and light. So we dive in. So the first question I have here is in 1989, it said, in a sound wave in air, the adjacent rarefactions and compressions are separated by a distance of 17 cm. Distance of 17 cm. The velocity of the sound wave is 340 meters per second. Determine its frequency. Okay, so the first thing we'll do is to acknowledge that wavelength is distance between ray refraction. The wavelength is distance between ray refraction. The wavelength here is 17 cm, that is 0.17. Okay, but the formula is given as velocity is equals to frequency times wavelength. Okay, so we have this as the first solving, that is frequency is equals to velocity over wavelength. That is making frequency such a formula from this particular formula. But we are not looking for wavelength. We are looking for one wavelength. For rarefaction, one wavelength is actually 0.17. 0.17 is actually converted from 17 cm. 17 cm will give us 0.17 meters. So ray refraction is actually adjacent ray refractions and compressions are half wavelength. So the full wavelength now will now be 2 times 0.17. So we are using this particular one to calculate the frequency. So again, frequency is equals to velocity over lambda, which is 340 over 2 times 0.17, right? Okay. So we'll be getting 340 divided by 0.34. The answer is 1000 hex. So C is the answer. Okay. So said when the tension in a sonometer wire is doubled, the ratio of the new frequency to the original frequency is, and there's a relationship between the um, frequency and the tension. Okay, so this is the relationship. Frequency is directly proportional to tension. So this direct proportionality relationship is the same thing as saying F is equal to, when we introduce equal sign and put K, we put the tension. So if I were to compare, F over root tension is equals to K. So I will have various comparison, initial frequency and initial tension to final frequency to final tension. So this is how it looks like. Okay, so now we're told that when the tension in a sonometer wire is doubled, the ratio of the new frequency to the original frequency. So there is this relationship of F2 over F1, that's from here, from here, this is it. F2 over F1 is equals to uh, b square root of T2 over T1, right? This is proportionality. Okay, so if, for instance, we're told that we should find uh, the ratio, say when the tension in the sonometer is doubled, so this tension is doubled, that's this one, this T2 becomes 2 times T1, right? Okay, let me put it like this again, over root T1. Okay, so this T2 is 2 times T1. Now, the uh, if the when the tension in a sonometer wire is doubled, so this tension is doubled, right? The ratio of the new frequency to the original frequency. So this one and this ratio is what? So I can cancel this. This will cancel this, and what I have is root 2. So F2 over F1 is equals to root 2. So this root 2 that is here is the final answer to this question. So the answer is C. Okay, so the next one here says let light of wavelength. This is the light of wavelength 5,000 times 10 to the power minus 8 cm travels in free space with a velocity of 3 times 10 to the power 8 meter per second. What is its wavelength in a glass of refractive index 1.5? So the formula for refractive index, for refractive index n, that's velocity in air or velocity in glass. So when you're comparing the two of them, you get the refractive index, right? So for um, glass, velocity in glass, I have the velocity in air. So I'm making this glass into the formula. So if this glass go up and come down, so I have glass here as the solution formula. N, this N is 15, 1.5, sorry, 1.5, and the air is 3 times 10 to the power 8. So by the time I compute, velocity in glass is 2 times 10 to the power 8. But wavelength changes with speed. It changes with speed. Wavelength changes with speed. So the wavelength is of glass is equals to velocity of glass over frequency. Now frequency is the same. The frequency of this movement in uh, glass and air is the same. It does not change. Okay, so that's it. Frequency stays the same in air. So I'm going to be getting frequency from here. If I make this one formula, F goes here and glass up under. So I'll be having velocity in glass. Uh, okay, sorry, I'll leave this one first. I'll leave this one first. I'll because since I said frequency is the same, right? So I'm going to be calculating the frequency based on the relationship between the velocity in air, that's free velocity in air, and the wavelength. Wavelength, and the wavelength is given as this. This is converted into meters by multiplied by 10 to the power minus 2. So this is the cm part and this is the meter part conversion. Okay, so F is equals to 3 times 10 to the power 8 all over what I have under here. 5,000 times 10 to the power minus 8 times 10 to the power minus 2. That will give us what I have here. That is 6 times 10 to the power 14 hex. So this frequency I've gotten here, I'll be using it for this particular formula, right? Okay, so that is it to have here. Okay, let me erase some of all this so that we can see what I'm talking about. Okay, very good. Okay, very good. So I have this particular one now, velocity in glass. This one is, sorry, wavelength in glass is the speed in glass. We've gotten speed in glass. This is speed in glass here, right? Speed in glass all over the frequency. Frequency is common to the two of them for glass and for air. We actually use the one for air uh, air to get the frequency that we use for glass. So by the time you compute, I'll be getting this particular value, which is equal to the answer. Okay. And number 4, 1989. This is has to do with magnification of the image of an object placed in front of a convex mirror is 1/3. If the radius of curvature of the mirror is 24 cm, what is the distance between the object and its image? So first of all, you know that this is a convex mirror. The convex mirror, the focal length is negative and the image form is also negative because the image is always virtual. Now, another thing too is that magnification given here shows that the image diminished. That means the object is 3 times the image. That's why it's having magnification of 1/3, right? Okay, and now we also were told that curvature of mirror is 24, meaning that the relationship between the curvature of the mirror and the focal length is 2f is equals to c, where f is focal length and c is the curvature. So from here now, the focal length is already 12, but I'm going to be using f is equal to minus 12. Why? This minus sign here shows that the mirror we're looking at is a convex mirror. So I'm going to divide my parameters. I'll say given that m is 1/3 and the radius of curvature is 12, 24. So I can get that my frequency is already, sorry, my focal length is already minus 12. So the next thing is that the mirror uh, curvature, radius of curvature r/2 will give us focal length, right? Okay, so now we're to use the mirror formula. Use the mirror formula. So this is the mirror formula. Sorry, magnification formula. So again, magnification is v over u, where v is the object, the image distance, and u is the object distance. But the minus here is attached to this v to show that the image is virtual. That is why you're having it as minus. Okay, so we're going to be expressing this. We know that already magnification is 1/3, right? From here, 1/3. So we're going to be putting it in this formula. Okay, so I have 1/3 magnification is equals to v over u. So this is the step down here. So the next thing is to make v substitute the formula. U will go upstairs and the minus will go to this way. So I have v is equals to minus u/3. So v is expressed in terms of u. You understand? U is still u and v is expressed in terms of u. So we'll go to the mirror formula. Put these parameters. Already this is f and the f is minus. Please remember because the focal length is negative. Okay, so I've put it here that the focal length is negative, so minus 12 cm. So we use the mirror formula. I have 1/v, 1/f is equal to 1/v plus 1/u. And I have this as f minus 12, and v is minus u over 3. See where we got v. Remember, minus u over 3. Okay? All right, so okay, so all right, this is where we are. So continue from here. So by the time you compute, you substitute f as 1 over minus 12. That's minus 12 as f here, and yes, and v as minus u over 3. You will get that u is equal to 24. It's a complex mathematics from here, but all you have to do is to put, okay, let me just go ahead, and how do we get to this point? 1 over f is minus 12, right? Is equals to 1 over v is minus u over 3, and 1 over u is u, right? So I can multiply each term by u, okay, or I can just do this 1 minus 1 over 12 equals to, so this one will now become minus 3 over u plus 1 over u, right? So here I cannot say get the LCM. The LCM here is u. This one is minus 3 plus 1 is equals to minus 1 over 12, right? So this and this, minus 3 and 1 is minus 2 over u is equals to minus 1 over 12. So I can cross multiply. So this u multiply minus 1 to get minus u, and 12 multiply minus 2 to get minus 24. So cancel, u is equal to 24. That's why I just solved it again, but I jumped from here to this point. Let me take off what I wrote here. The steps I wrote here, just take it off. Okay, so now I've gotten u. Right? I've gotten u. We have u. So we can find v from this formula. We can find v. Just put what u is there. U is 24. And v and 24 over 3. So v will give us 8. So I have u and v, object and image. So now this is where the final answer is. We say we should, what is the distance between the object and the image? So this is already object, right? And this is the image. This minus sign is just showing you that it's a virtual image. So it is not going to affect the computation when you are adding the two of them. It shows that this one is on one side of the mirror and this one is on the other side of the mirror. So the distance between image and object is actually 24 plus 8. That will give us 32. So 32 is the answer. So the next one is telling us that a hunter fires a gun at a cliff 408 meters away. Here's the echo 2.4 seconds later. Calculate the speed of the sound. So what's formula for speed? First of all, we know that this is total travel for sound to cliff and back is 2 times. You understand? So this one now, this is the cliff distance, right? But the sound will go to the cliff and come back. So let's say this is where the sound is. Let me just put my gun here. So it fires a bullet, right? So there's a cliff here, you understand? So this from where the gun is to where the cliff is 408. For echo to occur, if this speed bullet goes here, 408, it will come back again as echo. So the distance between the two of between and the gun flies, the sound now is the sound. The sound goes here first, and returns back, right? So it's going to be two times this, right? So I'm having this one as 816 meters. That is just for distance. But speed is equals to distance over time, right? If time is 2.4, speed is equals to distance over time. So I'm going to be dividing 216 by 2.4 to get this. So this is the answer. The answer is A. Okay, the next question, number 6, it says a wavelength or a wave has a frequency 50 hertz and a wavelength of 4 meters. Calculate its speed. So simply, speed V is equals to F lambda, where F is given as 50 hertz and lambda is 4 meters. So we'll just plug in the formula. V is equals to F, which is 50, times lambda, which is 4. So V is 200 meters. Okay. It says an echo is heard 30 seconds after a sound is produced. If the speed of sound in air is 330 meters per second, calculate the distance of the reflecting surface. So when dealing with echoes, remember, the sound travels to the reflecting surface and back. So it's a two-way journey. Sound goes to and fro, right? So I'm going to be adding the two of them. So the total time is still 3 seconds for this round trip. Okay, so the formula distance by time is there. So but since the time given is for the round trip, distance to reflecting surface is Vt over 2. Vt over 2. You know that this came from speed is equals to distance over time. Speed s is equals to let me call speed v, sorry, is equals to distance over time, right? So if this is distance, if I multiply both sides, I have s is equals to vt. That's how I'm having this one here now, but over 2. Okay, so substitute the values of speed substitute the value speed of sound. This is speed of sound, put it here, and time, put it here. Just simple. So I have this, and to give me 990 divided by 2, 495. 495 meters is the answer. Okay, so number 8 is 2008 question. It says an object is placed 30 cm in front of a converging lens of focal length 15 cm. Find the image distance. Find the image distance. So lens formula shows that 1 over f, where f is the focal length, u is the image distance, and sorry, p is the image distance, and u is the object distance, right? So we actually have focal length as 15 from the question, right? And the object distance as 30 from the question. Just plug into the formula. So I have 1 over 15 is equals to 1 over v plus 1 over 30. Make one over the formula, or the others go the other way. This one comes here, and this one goes here. Why? When this one comes here, it bears minus. Okay, so okay, see what happened. So it's what happened. So this is 1 over v is equals to 1 over 15. That is this one. Then this one joins it, then 1 over 30. That's why I have it like that here. So by the time I find the LCM and run it, I'll be having v is equals to 30 cm. Okay, so JAMB 2020 2001. It said a ray of light enters glass of refractive index 1.5 at an angle of incidence 30. Calculate the angle of refraction. Okay, so this is Snell's law. So this is just by diagram. Uh, this is the glass. So a ray of light. Let's say this is the normal. A ray of light enters this incident angle I, and this is the this incident ray, and this is incident angle I, right? So it enters like this, and angle of incidence is 30 degree, right? 30 degree, please. Okay, and the angle of refraction refraction. So it goes like this, it changes direction. So this angle of refraction is unknown. Snell's law states that refractive index is equals to sine of angle of incidence over sine of angle of refraction. We're given some angle of incidence at 30, right? So sine 30 all over sine r. And the refractive index is 1.5. So I'll put 1.5 here. So that 1.5 times this. So I say 1.5 times sine refractive index, sine angle of refraction is equals to sine 30. Sine 30 will have a value. So sine of angle of refraction is equals to sine 30 all over 1.5. Okay, so let me do this neatly. I think I have it already typed. So I want to erase this. So let's see the type version. The type version. Okay, so the next thing I'll do is to see that this is we'll plug in the values and we'll make sine r, so is the formula. By the time you do this ratio, this divided by this, it will give us 0.333. It's still equal to sine r. To get sine r, we just find the sine inverse of 0.33. That will give us 19 degree. 19 degree is the answer. Okay, so number 10 says a source produces wave of frequency 500x. If the speed of sound is 340 meter per second, calculate its wavelength. So the wave formula is wavelength is equals to velocity divided by frequency, and we're told to calculate wavelength. So just plug in the values there. Okay, sorry about this. We're not done yet. Okay, so we should be somewhere on 11 that we're in 12. Okay, so we go back and begin from the current slide. Thank you very much. Okay, so wavelength is equals to frequency velocity over frequency, right? So 340 divided by 500 will give us 0.68 meters. So B is the answer. Number 11 says stationary observer hears a sound of frequency 600 hertz from a source moving towards him at 20 meter per second. If the speed of sound is 340 meter per second, calculate the apparent frequency. Okay, so there's a formula for this. This is apparent frequency. Okay, so hold up. Okay, again, this is apparent frequency. And this is the frequency that we have here at 600 hertz. This is this frequency. This is this frequency, 600 hertz. And this velocity is the source velocity. And this is the normal velocity that we have. Okay, so okay, it's defined here. So I have F as 600 hertz, V as 840 meter per second, and source frequency velocity is 20 meter per second. So we'll plug all this in the formula. We'll be having apparent frequency f prime is equals to the frequency at of the sound, which is 600, then open bracket 340 divided by 340 minus 20. So by the time we resolve this to give us this one, then we'll just cancel out. So the final answer will give us 640 hertz. So number 12 is 2005 JAMB. It says if or an object is placed 20 cm in front of a concave mirror of focal length 15 cm, that's 15 cm. Find the image distance. Find the image distance. Remember that 1 over f is equals to 1 over u plus 1 over v. In fact, in optics, just know this mirror formula or lens formula. know them, know the convention, the signs convention for convex lens, for concave lens, or for concave mirror and convex mirror. Know which one is negative. For convex mirror, this is negative and this is negative, right? We're talking about concave mirror this time around. So it's easy, just plug in the formula, plug in the parameters. F is given as 15 cm, U is given as 20 cm. Put them in this formula. The rest will become mathematics. See, I have 1 over V is equals to 15. This one goes here and becomes minus. That's why it's having minus there. So by the time you do the LCM, you get V. V is 60 cm. That's the answer. Number 13 JAMB question here, 2010. It says calculate the critical angle for a glass to air boundary if the refractive index of the glass is 1.5. Glass to air boundary. So if I have this boundary like this, here is glass and here is air. So glass to air boundary, refractive index, and you have critical angle, right? Critical angle is what they asked to calculate, and you are given the refractive index of this glass as 1.5. Okay, so this is the formula. Sine C, which is the sine of the critical angle, is equals to 1 over n. What is n? N is the refractive index of the glass, so it's already 1.5 there. So I say sine C is equals to 1 over 1.5. And 1 over 1.5 is 0.667. So sine C is 0.667. Then sine inverse of 0.667 will give us C. And C is now approximately 42 degree. So that's the angle. Number 14 says a wave has a period of 0.02 seconds. Calculate its frequency. So what's the relationship between frequency and the period? Frequency is equals to 1 over t, where f is frequency and t is period. All right, so 1 over 0.02 will give us 50 hertz. C is the answer. Number 15 JAM 2014, it says a microscope has an objective focal length of 2 cm. So focal length F is objective focal length FO. Okay, the focal length is what? 2 cm. And the eyepiece focal length F small e is what? 5 cm. If the tube length is 20 cm, that's L is 20 cm. Find the magnifying power. Take near point as 25 cm. So look at the formula here. Magnifying power M is equals to length times focal length of the objective lens times the near point over focal length of the eyepiece. So just put the parameters as given there. We're given that the length is 20 cm. Where's the length? Sorry, 20 cm. The focal length of the objective lens is 2 cm and the focal length of the eyepiece is 5 cm. So just put everything here. And first part, this part will give me this 10. While the second part will give me 25, right? So I multiply 10 and 5, give me 50. 50 is the magnifying power. Okay, so number 16 says a water wave travels at 6 meters per second and it has a focal length of 0.3 meter. Calculate its frequency. Okay, so again, frequency is what we are told to calculate. I have this parameter, speed, and I have wavelength. This is just simple. V is equals to F lambda. Just make F the formula. F is equals to V over lambda. And F is equals to 6 over 0.3. So F is equals to 20 hertz. Okay. So number 17, it says a sound wave travels 1020 meter in 3 seconds. Calculate its speed. So this is wavelength and this is time. Okay, so how do you get it? Okay, so wavelength, that's distance over time, right? This is just simple distance over time. And then 18 2011 JAM, it says an object is placed 10 meters in front of a converging lens. A converging lens is, it looks like this. The lens that allows allows rays of light to converge after reflection. Converging lens. One is converging, one is diverging. This is converging. This one is diverging. This one is converging. Right? Okay, so this is converging lens, and this one is diverging lens, right? Okay, so converging lens, the rays of light appears to converge after reflection, while diverging lens, the rays of light appears to diverge after reflection. Okay, so an object is placed 10 cm in front of the converging lens, focal length 20 cm. Calculate the image distance. Again, like I said, this formula comes in very handy. 1 over f is equals to 1 over v plus 1 over u. So we're given these parameters. F is equals to 20 cm and u is equals to 10 cm. Okay, so I have you plug in the formulas, plug in the formula parameters. Then I'm going to be getting v as 20 minus 20. That minus 20 tells us that the image formed there is a virtual image, right? So 19 is JAMB 2013. See, a ray of light moves from air to into water. Refractive index is 1.33 at an angle of incidence 45 degree. Calculate the angle of refraction. Okay, so we just plug in the formula. Snell's law is the law that deals with uh, refractive index. So I have sign of incidence over sign of reflection. So refractive index, sign of incidence, sign of reflection. Okay, so 1.33 is equals to sine 45 over sine r. So I will just sine 45 is already 0.707, right? So I will make sine r as the formula. Yes, that's what happens here. So the next thing is to compute these two like this to get this. So sine r is sine inverse of 0.531, right? So the answer r is 32, approximately 32 degree. Okay, finally, I have a concave mirror has focal length of 25 cm and rays of curvature as what? So this one is testing us the relationship between rays of curvature and focal length, and the answer is rays of curvature over 2 will give us focal length. So if the focal length is 25, rays of curvature will be 50. Yes. So that's all for today. I hope our video is informative for you. I'd like to thank you for viewing. See you in the next lesson. Make sure to subscribe to our channel and engage us in the comment section. Thank you.